let's go through LeetCode 2935, maximal string pair XOR 2. For this question, it will give us an integer array nums. And it defines a pair of integer xy is called string pair if it is satisfies the condition. The absolute value x minus y smaller or equal to the minimal x and y. For this question, it says that the number, it is a positive number, right? So we can take a look. That means x minus y is smaller, the difference between, so for every number, if to form a strong pair with it. Let's look at the this formula, right? Because the x, y, they are positive. Assume x is a smaller one, right? So we'll have y minus equals x, right? So so what we need is that for those kind of y should smaller or equal to 2x, right? So that means for every number within 2 multiplied number, the bigger one should be able to form the strong pair with it, right? So for example, I have 1, right? So that means 2 can be form a strong number with it. So for that is upper bound. For the lower bound, we can see intuitively, we can see that is number divided by 2, right? But since that we can use some kind of values to try to test. For example, 3, right? 3 divided by 2, that is 1, right? But 3 minus 1, the delta is 2 is greater than 1, right? So this one we should be in the range numbers plus 1 divided by 2, right? So for every number, he can form the number in the range, right? In this kind of range to be strong pair with it, right? So as long as we get this kind of conclusion, we can do this question pretty much similar to the other questions, like 400. I think that is 421 and 1707. So we know for every number, it can be represent a binary sequence, a binary character sequence, right? So as long as it's integer, for example, we have a number for example 101, right? 101, and possibly there are 31 digits of it, right? So let's see, like a 5 can be represented like this, and every integer it can be represented use some kind of 0 or 1 index to it, right? So that means if we already have this number, right? If we already have this number, we can have this number array. We can create a chart structure. So that means this is a root, and for each chart it can be 0. For this root it's 0. This is 1, right? So goes here, it will be the first digits will be 0, and the first digits will be, I'll say this is 31 digits, right? So from the bigger to the smaller, for example, 0, 1, 0, 1, and we insert all of these numbers to the chart tree. For example, 0, 0, possibly 0 is 1, right? So So we do the preparations to insert the numbers into the char tree. And to find the maximal XOR, what we are going to do is that for every number, right? So if we have number in the chart, what is the biggest XOR of it is that we also iterate from the root. So for this node, we try to find its XOR node, right? So if this is 0, then we try to see whether 1 exists or not, right? So if it 1 exists, right? So in order to get the biggest XOR number, we should get the upper, the highest digits different as possible, right? So what we are going to do is that we are going to go to its XOR path, and now we have 1, right? And after here, right? So we'll see this one, its XOR 0 also exists, right? So we'll see for this digit, that's 30 from the left to right, that is 31 digits. The XOR is 1, right? So it will add out to our result. And also this 1x0, this is also 1, right? So assume this does not exist, right? Does not exist. Whatever we do, we should still, I mean, from here 0, the 1 does not exist. Do we need to continue? We still need to continue because it's possible under the children root, it may be have some differences with the number digit bit, right? So what we do is that we iterate from the root to the leaves about the nonce, right? And find its XOR root. So the principle of that to find the XOR root is that if we have XOR bits for this digit, we are go to the XOR bit. If it does not have it, right? So then, for example, this 0, it does not have 1, then it also go to 0, right? So the thing is that there is one thing is that for this number, every number it's already insert. They have the same length, right? So it's not possible just the sum of the char end or terminate early, right? So if we go to here, right? If this doesn't haven't finished, so this kind of node will at least have one child, right? So in this case, we find the XOR of a number, right? The thing is that this XOR, they need to find have a limit of it, right? So to handle the limit is that for every child node, we add a minimal value and a maximal value represent under this chart the minimal value in this chart, and the max value is that under this chart under this node, right, under this tree, the max value of this chart. So so we just add another condition, that is when we try to find its XOR path, right? If the first thing is that we have this principle is that if the XOR node exists, right, then we go to the XOR node. If that does not exist, then go to 0. And also we need to check, for example, this kind of under this kind of node, with all of the childs, they are in the limit of our minimal and the maximal, right? So for example, if we trying to go to this path, if all of the subtree, the maximum value is smaller than our is smaller than our lower limit, then we cannot go to this path, right? So we have several conditions for this, right? So this is just the I have another explain another question of 1707. We can go through that question again if you have question on this part. So let's begin to write code for this. So we are going to create a charge node for the we are going to have array, right? Array for children. So this is bit, right? Bit can be only be 0 or 1. So we know it will be a size2 array. Node. So I say children equals new child node 2. And for every node, we add two values. One is its minimal. That means under all of the child numbers, right? The minimal values of it. So let's set the initial value as integer dot max value, and we have a max initial value as integer dot mean value, right? So we write first write the insert function, private provide insert, right? Let's create a child root equals new child node. Okay. So what we do is that we have child node parent equals root, right? At the beginning, when we insert, we are also update the mean value for this kind of, right? So that is parent dot mean equals mass dot mean parent dot mean and the number, and also current dot max, right? Equals mass dot max current dot max number, right? It has a length to be small or equal to 20, right? So we can write for I equals int I equals 20, right? I greater equal to 1, 0, I minus, right? So we'll have the bit int bit that is from the left to the right, the ith digit or ith bit is number right shift I and 1, right? So we'll say if it's child current dot children bit equals null, then we'll create no channel for this current dot children bit equals new child node. Okay. Then we move current to a current dot child. And the thing is that we also need to update the every time we move to a node, right? We need to update this kind of value, right? Means every child tree, the children, right, or the biggest number and the smallest number, right? For the last one, which is a leaf, we insert one more, but it will not affect our result, so it is fine. Then we can have an private int find max into number, right? So we'll have a upper limit and a lower limit, right? Upper and lower. So that will be our upper limit and the lower limit. So that is we also have our child node current equals root. So we'll say if current dot mean greater than upper, that means for our root, right? Our root, the minimal value is already then our upper limit. For example, if we have 2, right? The minimum is already great than 4. Then we'll not have any result. Or current dot max is smaller than or lower. Then we just return -1, right? So also we need to have a result. So this result is our max XOR of this number, right? Let's set as 0. So this means it will have some values, right? So we'll also set int I equals 20, I greater equal to 0, I minus. So we'll have int bit equals num right shift I and 1, right? So we have satisfy these 3 conditions. One is our current dot children bit XOR 1 than equal to none, right? In that case, we will go to this current child bit XOR 1 path. Or and we'll say and current dot bit children bit XOR 1. We should have its minimal, right? Should smaller equal to upper, right? Otherwise, if it's minimal greater than upper, if it's already then, for example, 2, it's already greater than 4, that path, of course, will not satisfy our result. And we'll say, and its maximum should greater equal to lower, right? Greater equal to lower. So the same thing is that if it's maximal, but the maximal for 2, right? Maximal is smaller than 1, for example, 1, right? Those kind of part we cannot go to that path as well, right? So in this case, what we're going to do is that we'll have result should add to the ith digits. The we'll have 1 shift left shift I, right? So this kind of digit we should add as 1, and let's set as bit XOR 1, or 1, right? Otherwise, we just go to just the bit with the same with the number, right? So if this kind of if does not satisfy, then we are not change the bit. So current equals current dot children bit and it return result. So what we do is that for every number, right? Let's say we need to have a sort. It's not arrays sort this kind of number. So we need to sort. Actually, we don't need, right? We don't need sort to do it like this way. It's not need to sort. So because we are search with limit, so we don't need to sort. There is so for this question, if we sort, the time complexity will be n log n number, right? And but we do not sort, that is O(n) multiplied by 20, right? So the time complexity will be better than sort. So if we so what we do is that we for every int num and num we get the insert, right? We insert num, and we are going to have a global max in the result equals global result, right? We want to find the maximum value, so we'll have initially set this as the mean value, right? So what we do is that for every num in nums, we are have result equals max result, and find max num. What's it mean? Minimum will be num plus 1, the lower limit, right? And the upper limit is num multiplied by 2, right? And then in the end, we just return result. Should be low. There, insert me, me, and then so the length is mm, did we insert correct? I think it's a bit okay. Find the max. Ah, that it's reversed, right? So upper. Let's put it up here, right? This is upper. This is low. Okay. the time complexity will be ON multiplied by 20, right? Space actually, it will be, how can we say that? It's a char, right? Char space, should be bigger than n multiplied by 20, right? Because the length, right? This is just if we or we use a node to save multiple values, should be if every number we stored like 20 chars, that will be n multiplied by 20. But this one, I think it will at least save at half of the space.